Hello, my mathematicians! This is Miss Foster with Math in Focus, Grade 4, Chapter 6, Lesson 4, and today we are looking at improper fractions. Now, improper fractions are ones that have a larger number in the numerator than in the denominator, and because of this, they sometimes make me feel a little bit seasick. Like, look at this one right here, 13 tenths. Ugh! Ugh, it just doesn't look right, does it? That's why they're called improper fractions. But then after a long time of working with fractions, I began to realize that improper fractions are really great. For one thing, if you've got a grade with an improper fraction in it, you've gone above the highest grade that you can. You've got extra credit. That's super awesome. So remember, you always have permission to be an overachiever at Wellington. Just, do you, but if you need to be awesome, be awesome. The other thing I realized is it meant that we had leftovers in the fridge. Like if I made really great cookies, and 3 were left over, woohoo, I'm winning. So improper fractions can also be. So Mr. Williams has some strips of wire, and the wire is measured in 1/3 meter units. So here he's got A, which is 1/3, looks good to me. Here he's got B, which is 2/3, still a happy fraction. Here he's got 3. 3/3 is equal to 1 meter. Now 1 would be the simplest form, but since we're talking about improper fractions today, let's not put it in its simplest form. Sometimes you need to take it to a less simple form. So 3 out of 3, 3/3. And this one is where we get into the improper fraction. Right here, this is 1 whole meter, right? And so we've got 3/3 here and another one here. The simple form is 1 and 1/3, but if we wanted to write it with improper fractions, we'd write it as 4/3. So strip D is 1 and 1/3 meters long. There are 4/3 in 1 and 1/3, and so we've got 1, 2, 3, 4 4/3 in 1 and 3/3. All these are improper fractions. Let's look at these pie pieces over here. I've got 5 pieces here, 10 pieces between these two, plus another 2. That would equal 12 pieces. But how big are those pieces? What are those pieces even called? Well, let's see. 1, 2, 3, 4, 5. Looks like I have 5 in one whole thing. So I have 12/5. Another way to think of it is kind of like that. If you've got whole things and you want a certain fraction of them, you can ask how many of the fraction are in that whole group. Here we've got a group of 2½ green circles. How many halves would fit into these 2½ green circles? Well, we can divide the first one in 2, second one in 2, and the third one's already divided. So we've got 1, 2, 3, 4, 5 halves in 2½. All right, let's try these shapes over here. I've got 4, 5, 6, 7. That makes 7/4. Here, each one of these things has been divided into 2 groups. So that would be 2, 4, 6 pieces. But there are 2 in just one of them. Here I've got 1, 2, 3, 4, 5, 6, 7, 8. 8 pieces is how many I have. But how many in one whole thing? 1, 2, 3, 4, 5. 8/5. And those are improper fractions. Again, they're great if you're trying to do grades. Now, I wanted to show you this picture in blue because it shows the mystical magic of simplifying just so beautifully. Remember, when we simplify fractions, we get to an equivalent fraction by dividing by 1 represented by a fractional part. And I think it's the only time that magic happens in math because you can literally uncut something. Doesn't happen in real life, but you can do it in math. So here we have 14 tenths. Looks like there are 10 pieces in one whole blue rectangle, and we've got these extra 4. So what I'm going to do this time is divide by a common factor. Well, 14 and 10 are both even, so I'm going to start with the common factor of 2. Now, 2 halves is equal to 1, so I'm not changing my amount. I'm just literally through dividing, taking away this cut and this cut. And look what I have. 14 divided by 2 is 7, and 10 divided by 2 is 5, and look, those cuts are gone. Let's try simplifying 15/6. What is a common factor between 15 and 6? 3. Yes. So 15 divided by 3 equals 5. And 6 divided by 3 equals 2. That's 5 halves. This one's a little harder though. 26/12? They're both even. I'm just going to try dividing them both by 2 halves again. So 26 divided by 2. Let's see. 6 divided by 2 is 3. And 2 divided by 2 is 1. I'm at 13. And then underneath there, I've got 12 divided by 2 is 6. So we've simplified this improper fraction to 13 halves. And you can see how they work out on a number line here. This number line, whoa, this is 1 and this is 2. And you can see we need to put some improper fractions over here. So 1 and 2/3. Well, I'll definitely have thirds for that one. In one whole thing, there are 3/3. So if I have 3 for the 1 and 2 for the fraction, that would give me 5/3. Let's take a look at 1 and 5/6. Well, if these are sixths, there will be 6 in the one whole thing. So 6 plus 5 equals 11 sixths. And let's try this too. Now I can choose, do I want to do it in sixths or thirds? I want to do them at both. So 2 is equal to 6/3, because there are 3 in each whole thing, and 3 times 2 is 6. Not your best 6, Miss Foster. There we go. And that will also be equal to how many sixths? Well, 6 times 2 is 12. So all of these are equal to each other. Fractions kind of make my brain spin a little bit. So if you get lost, go back and watch this again. Or get out those fraction models that we sent home with you. Or draw lots of bar models, because you can use those with fractions as well. To practice these concepts, please complete pages 157 through 160 in your workbook. A grading master can be found in the Distance Learning Google folder for April 13th. Please grade every time you do one page. That way you can tell if you are confused or if you've got it. And if you're confused, rewatch this video, use those fraction bars, draw bar models, or get with a teacher during office hours. Hey guys, thanks for playing math with me. I love playing math with you. Bye-bye for now.